Dynamic loudspeaker simulation in QuickField. Loudspeaker consists of the voice coil, diaphragm, steel core, and a permanent magnet. My task is to calculate the inductance of the voice coil. The inductance is an important parameter that determines the dynamic characteristic of the loudspeaker. And it is important to calculate the inductance with respect of the actual saturation level of magnetic material. You see, the core is made of soft steel, which magnetic permeability is not constant. Here is the pH curve. And the saturation level depends not only on the current in the coil, but also on the permanent magnet. In this example, I'm going to demonstrate how to calculate the saturation level and how to pass the magnetic permeability distribution from one problem to another problem. The geometry features rotational symmetry, so I'm going to simulate two-dimensional magnetic problem. Okay, let's start QuickField now. In QuickField, I create new problem. Loudspeaker DC. Next, problem type is magnetostatics, length unit some millimeters, and the model class is axisymmetric. Axisymmetric model class is used to simulate the devices that features rotational symmetry. Finish. On the left you can see the problem pane, and on the right you can see the geometry model editor window. You can draw the geometry here, or you can import the geometry model from the AutoCAD DXF file. Here is the file, and I will import the model. In axisymmetric problems, the axis of rotation is a horizontal one, and you should draw only the upper half of the model, because the bottom half is the same. So I will switch to insert mode, draw the line on the axis of rotation, then switch to select objects mode, select these objects, click delete and remove them. Okay. Now here you can recognize steel parts, the permanent magnet, and the voice coil. But in fact, the magnetic field is distributed not only in these parts, but also in the air outside. QuickField cannot calculate field distribution in the infinite space. We should limit the simulation domain. So again, switch to insert mode, change the line type to half arc, and draw the air block boundary. Okay. Next step is to assign labels. Through labels we will explain the geometric object's meaning and provide material properties. Switch to select mode, click to select the block, and assign label air. The label appears in the tree. Click here, this is the permanent magnet. This is core. And this block is core. And here is the voice coil. And I should also assign labels to the boundaries. QuickField automatically assigns proper boundary condition at the axis of rotation, and for this arc I will assign label external. Now let's provide physical properties for these labels. Double-click label name in the tree. Relative magnetic permeability of the air is 1. Okay. Relative magnetic permeability of copper is 1. The current in the voice coil is 0.1 ampere, and the conductors are connected in series. Okay, if you zoom in, you'll see there are many conductors in the voice coil. For the permanent magnet, the permeability is 1.05, the course force magnitude is 500 kiloamperes per meter, and the direction is 0 degrees to the right. Okay. For the core, I should specify the BH curve as the permeability is nonlinear. Okay, click here. In fact, I already have the data prepared here in the Excel file. So I just select them, copy, and paste it here. Close. Okay. Far away from the loudspeaker, magnetic field fades to 0. So at the external boundary, I specify 0 magnetic potential. Okay. The geometry model and material data are ready. Before I start the analysis, I should build the finite element mesh. Just press this button and the mesh will be generated. Now, save all problem files and solve the problem. And you can take a look at the results. You can see the field lines now, and you can adjust the field picture and switch on the color map of the flux density, or choose some other value, for example, permeability. The correspondence between colors and numbers you can see in the legend. My task is to calculate the coil inductance. Inductance is the ratio of the flux to the current. To measure the flux, I can use the contour tool, click and drag to draw the line here, then follow to the intervals and calculate the magnetic flux. But wait a moment, this is not the flux generated solely by the coil. This is a total flux generated by the coil and by the permanent magnet. And there is no way to separate them. So I cannot calculate the inductance by dividing this flux value. I need only the flux generated by the coil. Well, I can remove permanent magnet from the model. But then the core saturation will be lost. And it is important to calculate inductance with respect to the actual saturation of the core. If you zoom in, you will see that the core magnetic permeability is not uniform. Some parts are saturated more, some parts are saturated less. In QuickField, you can pass the magnetic permeability distribution from one problem to another. And you can even pass permeability distribution from DC to AC problem. So let's create new problem. Loudspeaker AC. Next. Problem type is AC magnetics. frequency is some 10 kHz, length you need some millimeters, model class is axisymmetric. I'm going to pass permeability distribution from one problem to another. Problems should be based on the same geometry model file. The geometry model file name in DC problem was Loudspeaker DC, and in this problem I should use the same model file. So I click here, browse, and this is Loudspeaker DC. QuickField model file. Open. Finish. Now we have AC magnetics problem, and the geometry model is already here, and the labels are already assigned, but we should specify properties for these labels. For the air, I specify the magnetic permeability of, well, hold on. I would like to pass permeability from DC magnetic problem. Cancel, open problem properties, follow to the link step, magnetic state, browse. I would like to import the magnetic state from Loudspeaker DC problem. Add. Okay. Now the magnetic state will be imported, and for these blocks I can specify any value of the permeability. For air, 1, for core, 1, for permanent magnet, 1, and please note I do not specify the Corsair force here. For the coil, permeability is 1, and the total current is 0.1 ampere. Conductors are connected in series. And again, far away from the loudspeaker, the magnetic field is 0. Okay. Now let's run the analysis. The problem has been solved. Let's take a look at the results. And now you can see the magnetic field that was generated only by the coil. There is no permanent magnet here. Let's check the material saturation level. Field picture properties, color map of the permeability. Okay. These are the same values that was in DC magnetic problem. So now I can calculate the inductance with respect to the actual saturation level of the core. I will use the integral calculator inductance wizard and calculate the stored energy. Next, calculate energy, and the current is 0.1 ampere. Next, finish. This is the inductance of the voice coil. If you search for the loudspeaker on our website, you will find the example page. Here you can read about problem setup, browse the solution section, take a look at the resulting pictures, and download the simulation files. Simulation files may be opened and the results may be viewed using any QuickField edition, including QuickField Student Edition, that you can download from our website for free.